Let's look at example B, which is sine of 345 times sine of 255. Again, I use my cos diagram to determine where these angles are. 345 is smaller than 360, bigger than, so I am in quadrant number 4. Whereas 225 is smaller than 270, bigger than 180, so I'm over there. So in terms of quadrants, I'm in quadrant number 4, and I am in quadrant number 3. If I looked at the signs, over here sine will be negative, and over here sine will be negative. So both of them are going to become negative signs, which is perfect. Anyway, let's go ahead and move forward. What are we going to do? We are going to reduce. Reduction means we're going to go as close to our 360 and 180 as we can. You're going to rewrite this angle as a relationship, a plus or minus relationship over there. So this becomes sine of what? Because we're in quadrant 4, 360, and the other one is going to be sine of 180 because we are in quadrant number 2 and quadrant number 4. This should make sense to you. Okay, so how do we get our first one? We're going to say 360 minus 245. That gives us a total of 15. So this is minus 15. And our second one, now I'm not going to say 180 minus. I'm actually going to say 255 minus 180. That gives me 75. So 180 plus 75, that gives me 255. Beautiful. So plus 75 degrees. That is what my reduction looks like. Okay, now let's go ahead and get rid of our highlighted angles, and we're just going to simply reduce. So I'm keeping my sine 15 and my sine 75. I got sine of 15 degrees times sine of 75 degrees. That's what I'm keeping. But now the question is, what is the plus minus sign in front of them, right? Okay, so in quadrant number 4, we said here sine is negative. Why is that erasing? Sine is negative over here. So this is negative sine of 15 degrees, which is what we know to be true. In the blue quadrant, tan is positive, sine is negative. So this is negative. So we've got two negative angles multiplied by each other. Minus and minus cancel out, so our next step would be to write it without the minus sign. We've got sine of 15 multiplied by sine of 75 degrees. Okay, now, is this usable? At this point, not really. Yes and no, because your biggest issue now is going to be that 75 degrees. That's not a special angle and it's not matching, right? And you don't have anything that says sine sine. So instead, what we're going to do is we are going to say sine cosine. So can we convert our sine of 75 degrees to a cosine? Okay, so let's first convert it to our 90 minus. So 90 minus 75 gives us 15. This ends up being sine of 90 minus 15, sorry. Minus 15 equals 75. And once we've got that, we can change this using your co-function. And your co-function says this is in quadrant number 1 where everything is positive. So this is cos of 15 degrees, which means now we have sine of 15 degrees multiplied by cos of 15 degrees. This is great. Okay, it still doesn't look like anything that we want it to look like. If we go back to our rules, what you would want it to look like would be 2 sine cos. Okay, if we were able to do something like that, then we are going to do the same thing we did when we were doing what's the word for it? Completing the square. So I want you to multiply it by half and by 2. So what happens now is because, okay, we can actually put the 2 on the inside of the bracket. Now that you have 2 sine cosine, you can actually convert that to sine of 30 degrees. So we have now a half multiplied by sine of 30 degrees, which is great because sine of 30 is a special angle. So now we have a half of, and again, if you could just recognize it's a special angle. Once you know that, you can use your calculator. Sine of 30 degrees gives us a half. So half multiplied by a half gives us an answer of 1/4. There you go. Example B.